Welcome back to our online summit here at Pepperl+Fuchs, and today it's about Ethernet-APL. You've arrived at our live lounge, and this is the opportunity for you to ask questions. Just use our live chat. You can find the button on the lower right side. And we already got a good impression why Ethernet-APL is needed and where. For example, in this field instrument, it can provide many values. For example, pressure, of course, density, volume, etc. But Ethernet-APL can transport all these values. So more about the advantages of Ethernet-APL. Join me on stage, Andreas Hennecke.
Thank you, Oliver. I am Andreas Hennecke. At Pepperl+Fuchs, I'm part of the development department and responsible for technology and product marketing for digital communications in process industries. I support various marketing working groups that are also part of the APL project, the conglomerate and group of companies that are developing Ethernet-APL. In the next 45 minutes, I would like to give you an inside look and the technical details and background on the function and designs that provide the basis for Ethernet-APL advanced physical layer. But why did the designers even choose Ethernet? Maybe we need to ask a different question. Could we ever imagine a life without an Ethernet? Let's have a look.
Ethernet enables high-speed communication, transports large data generated in production. It enables the coordination of complex tasks, handles data traffic in warehouses. It connects computers in our office environments and our smart TV and game stations to the Internet. Ethernet is the accepted communication standard for networks.
So please join me. I have prepared the details to explain Ethernet. There are three different things that we will cover in the next minutes. Definitions for the physical layer, what actually constitutes a physical layer. Installation concepts that will allow you to implement Ethernet into the field. And compatibility. What we will take is a look at how actually Ethernet can be applied immediately in process industries and inside the plant. Well, we started with this device. And having a self-contained device would allow this device to bring you the manual, the documentation, and even the device drivers that your DCS needs to connect with the device directly inside the device. And Ethernet will allow us to connect it. And thus, along the entire work life cycle, everything is stored in the device as designed, as we're getting the information such as manuals and engineering, as built with the tag information stored inside the device, and of course as maintained as the device now holds also all configuration information and can better send diagnostic data. So when we think of Ethernet, what do people think when they think Ethernet? Let's have a look. Think of Ethernet, and when people think of a connector like this, you plug it in, and your device connects to the network. No matter what the age of the device or the speed that it connects with, it always works, no questions asked. This does not work for the field of process automation, where we're looking for something more ruggedized, like a two-wire cable. This provides us with the installation simplicity that is required to work in the field of a process plant. Ethernet-APL is all about defining the standard that allows us to bring Ethernet to the field of process plants. So this type of cable provides high resilience to electromagnetic interference. But there are a couple of limitations that Ethernet has today that we need to overcome. First, we have to overcome the 100-meter limit of cable distance that we can cover. And there are also some power issues that we need to bring because the two-wire cable not only does communication, it also transmits power to the field instrument. Hazardous area protection is obviously extremely important for many of our users in process industries. And as a side benefit, we're getting a lot more speed with Ethernet to the instrument. So there are 4 aspects that actually constitute and are part of the physical layer. There's communication, power supply, installation technology, and explosion protection. Let's look at all 4 of these and how the Ethernet-APL project is working to standardize these and publicize them in such a way that all participants in the market of process industries can join and utilize this physical layer. First, communication. There are 5 different standards and working groups working on different standards for a 2-wire single-pair Ethernet. Let me just give you one example. Right now, the working groups are defining a 2-wire Ethernet that can go up to 10 gigabits per second on 2 wires. Well, they will only cover a distance of about 15 meters with that. The application for this is the data centers where high-power computers need to communicate to each other and to the network. So this type of an Ethernet definition on single pair will allow computers to communicate inside the data center, inside one cabinet. Now, for the process plant, we're a little bit at the other end of this scale. The 10 megabit Ethernet is defined for a cable length of up to 1,000 meters on a shielded twisted pair wire. This is the communication that Ethernet-APL utilizes. Now that's just not enough. We have covered the communication part. Let's look at number 2, the power supply. Now, there is power over Ethernet, also called POODLE, and while a lot of people not familiar with the topic think of dogs, it's actually power over data line. Power over data line is not quite what we need in process automation because we need different power levels that are also adjusted to process automation needs, such as explosion protection. So you can already see these are very intertwined. Ethernet-APL defines power up to 92 watts on the cable. It is polarity independent, which makes the connection simpler. And there are 4 different types of ports that we have defined. Where the power source port and the load port are quite obvious, you can also run Ethernet-APL unpowered when you already have devices with an external power supply where that external auxiliary power is available. And most interestingly is the cascade port. This is a type of port that will auto-adapt to become either a source or a load port. And we will see later how that allows us to daisy chain devices on a single pair Ethernet cable. Point number 3 in the definition is the installation. Now we've seen the 2-wire cable, and the cable type A, which is familiar to many of our users, is the standard cable. The other thing that we have is the screw type or spring connectors that you see in the picture here. And for those that are preferred, we have M8 and M12 connectors also specified. These are 100% compatible to each other. For explosion protection, intrinsic safety is of the essence. And intrinsic safety now again plays into the power consumption of the device, as it is a way to limit the energy on the cable. If you're new to intrinsic safety, please ask your Pepperl+Fuchs specialist to give you an inside look how this could help make your plant safer and cost-effective to install. Now, intrinsic safety requires our users to do calculations like you see here for each and every loop. Now, with Ethernet-APL, we want to make this a lot simpler. So one standard that we're developing at right now, and actually this standard already has a community draft that is up for review, is called 2WISE. And that stands for 2-wire intrinsically safe Ethernet. It defines interoperability by specifying precise values that the manufacturers and vendors have to keep in their instruments. So thus, it provides our users with a very simple way of planning the networks and validating and verifying without any calculations that that the circuits are intrinsically safe. This method is inspired by FISCO, and matter of fact, that is the Field Bus Intrinsically Safe concept. And some of the people that are right now serving on the two-wise committee of the IAC were the same ones that also defined FISCO 25 years ago. So what does this mean for you? You basically select your apparatus, the switches and the instrumentation according to the value set for your hazardous area. You select a suitable cable and install it. Keep obviously to the cable limitations such as cable lengths. And you need to document all these, and then you're done. Intrinsic safety is validated. So we have now covered all four aspects that constitute a physical layer. Maybe you noticed I have not talked about one single protocol yet. And that's the important part, that a physical layer will actually transmit and transport any type of protocol that you choose and that you would like to see utilized in your plant, so the project of your choice. This is all the part of defining Ethernet-APL. There are 4 user organizations supporting this project, such as the Fieldcom Group and ODVA and Profibus International, which were the first to join. And just recently, in July, the OPC Foundation joined the club. There are 12 vendors supporting this project. Important and very well-known names on the DCS side, such as Yokogawa or Siemens, Emerson or Rockwell Automation, and ABB. On the instrument side, we have very well-known companies such as Anderson Hauser, Krone, or Vega and Samsung, which are part of the team. All of us are working together to create a physical layer that will allow you to apply this data highway in your process plant, and we're inviting, of course, everybody in the market to participate. And with Ethernet technology, that is also very simple. So we have learned now together what the aspects are of defining a physical layer. Let's take a look at how this is actually applied in the process plant. Here are the different concepts and terminology for Ethernet-APL. Let's take a look.
The Ethernet Advanced Physical Layer fits any process plant, as the installation architecture provides flexibility and explosion protection for all types of hazardous areas. But first, let's look at the terminology for Ethernet-APL infrastructure and components. Segment is the connection between switches, or between switches and instruments. The trunk is a long-reach cable with up to 1,000 meters in length, with high power and signal strength. The spur is a connection cable to an instrument, with up to 200 meters and lower power and signal strength. Spurs can be implemented with intrinsic safety. Ethernet-APL only defines point-to-point connections. Its communications are robust, as crosstalk between segments is practically impossible. There are just 2 kinds of switches needed to support the complete infrastructure. One is the power switch, which provides power to the trunk line, and the other, the field switch, which provides power to the spur line where the instrument is connected. This is the infrastructure for Ethernet in the field. The top level consists of controllers, process visualization, engineering, and asset management systems. Other connected systems may be cloud-based, such as long-term data storage. Ethernet-APL connects to the top level inside the control cabinet. The switches support ring redundancy for high availability. Next, let's take a look at the Ethernet-APL infrastructure and topology for long-reach plants, common in outdoor installations like oil and gas, water treatment, and chemical plants, with cable lengths up to 1,000 meters to the field. Here, the power switch is installed in the control room. It provides the power for field switches and instrumentation. The field switch, which is powered via the trunk, provides the intrinsically safe barrier for the spur outputs. It serves the following attributes and requirements. Field switches that are powered via the 2-wire cable. Distribution through the junction box in the field to multiple instruments. Supported Ethernet redundancy at the plant level. And explosion protection for any hazardous area. This layout is 100% compatible with the trunk and spur topology, similar to today's Field Connect solutions with power hubs, field barriers, and segment protectors. It provides a path for migration projects, as the installed cable can be reused. The Ethernet-APL infrastructure and topology for compact plant layout typically serves indoor installations, such as pharmaceutical or food and beverage industries, with cable lengths of up to 200 meters into the field. The topology is called a star topology. The following typical attributes and requirements apply. Field switches that are powered by an auxiliary power supply. Installed in junction boxes or control cabinets. Supports Ethernet redundancy at the plant level. And explosion protection for any hazardous area. Using only these elements, any combination and layout can be achieved. Pepperl+Fuchs is known as a pioneer and an innovator in electrical explosion protection and communications for the field of process industries. Pepperl+Fuchs will bring safety and stability to your network with Ethernet-APL.
So Ethernet-APL provides the flexibility to adapt to any plant and any process and any geographical setup. And it only takes 2 types of devices. At Pepperl+Fuchs, we're developing various product concepts to support all these topologies for different applications. The first type is a field switch for DIN-Rail installation. It provides at its output APL spur power and communication. It supports ring redundancy to the facility Ethernet, which you see with the 2 black lines. It is powered in the cabinet, can be installed inside the cabinet and the junction box. Outputs can be intrinsically safe for any hazardous area protection. The APL power switch by Pepperl+Fuchs powers the trunk. It also supports ring redundancy and resiliency concepts for your Ethernet inside the cabinet installation. It obviously also connects to auxiliary power supply. Can be installed in Zone 2 or Division 2. And the field switch is the one that will feature the cascade ports. No matter whether or not the power comes from the left or the right to this field switch, the ports on the trunk of this field switch will actually automatically adapt to the power flow provided. It provides outputs that can be intrinsically safe for instruments in Zone 0 and Division 1, and it can be installed by itself in Zone 1 and Division 2. So those are the concepts of Ethernet-APL. And with Ethernet-APL, we're actually getting to what we're looking to do for the instrument and with the instrument is improving the value along the plant's life cycle in every aspect, because all information can be directly accessed and concurrently accessed from where you are. There are 2 application examples that we have for, and I would like to cover them with you, safety signals and, first of all, modernizations and expansions. Ethernet-APL provides a very clear path forward for our users of Fieldbus. Let's consider this small setup here. In a plant, Profibus PA field devices will be connected to the DCS system with a field barrier or a segment protector. This communication is well established and in use for 20 years, and we have lots of operators that enjoy already the benefits of digital communication in the field. Now, in order to migrate from this setup to Ethernet-APL, something very simple needs to be done. We replace the field barrier or segment protector with the respective field switch. It will automatically adapt because it can detect whether or not a field bus device, foundation field bus or Profibus PA is connected, or an Ethernet device. Now this also allows for very smooth integration and migration projects, because if you need to replace this device, you can simply remove it and replace it with a respective Ethernet-APL device, for example, a Profinet device. Again, the switch will detect this and automatically adapt. So we have a very clear path for you to migrate from an existing plant with field bus to Ethernet-APL with any protocol that you would like to use. And finally, let's talk about safety for just a moment, because we're at a very unique junction where safety could become part of this infrastructure. And there is a data highway available for this, for safety data, which rides piggyback on any existing digital communication. This communication concept is called a black channel. This black channel basically ensures that the communication between a safety device and a safety PLC can be SIL3 certified, even though we do not even know what type of connection is in between. That's why we call it a black channel. And what you can see here, these are just basically copies from the individual organizations of implementation and explanations of the black channel. So this concept is already very well established and is utilized in discrete manufacturing, where an emergency stop button or a light curtain actually protects workers and the plant and keeps them safe. With all of these technologies available, with Ethernet-APL, we have a unique opportunity to integrate this concept and safety into the instrumentation. So we have a common and straightforward approach for both the vendors and the users in process plants. And Ethernet-APL has the opportunity to become the shared infrastructure for both process communication and safety signals. So this reduces our effort and cost in the infrastructure as well. So what we have in summary with Ethernet-APL, take a look. The Ethernet Advanced Physical Layer provides the data highway for concurrent access to the device, from the controller to the instrument, for operations with high precision data for superior plant performance, for maintenance and inspections, with live data on the go via tablet or an app, for engineering, with complete data for planning or applying changes to the system. And all of this is independent of your device or location. The right data is always available with Ethernet-APL. At our webpage at www.pepperl-Fuchs.com/APL, you can download a white paper that provides all the details and the detailed descriptions also for different users, such as the engineer and the operator and the technician. You will also find this white paper here at our Summit website. I am Andreas Hennecke, and thank you for watching.
Thank you, Andreas. Now move aside a little. Thanks a lot. Yeah, it's always a little difficult. Actually, there's a question concerning the communication of Ethernet-APL, whether it's half duplex or full duplex.
Yeah, interesting question. Ethernet-APL actually communicates full duplex. So we have 10 megabits in both directions simultaneously. This is different from existing communication that we have from a two-wire cable. Ethernet-APL can actually do full bandwidth in both directions. So that gives us actually double the speed on top of the 10 megabits we already have.
Okay, and now a little view, maybe in the nearer future, will there be devices available from any vendor with Ethernet-APL?
Yes. Well, in the near future, this might be a little bit of a problem because obviously we've been talking about a technology, and developing a technology is the first step. Implementing it into products is the second step. So the company supporting the project today actually will have products available sometime next year actually at ACHIMA 2021, where we're going to show first product. Then obviously it's going to take a little while for the companies to adopt their entire product portfolio. And once the standards are published, it is possible for every vendor to actually utilize Ethernet-APL physical layer, because we're going to have chip manufacturers available that provide the chips. And Ethernet-APL is also a very well-known, well-established technology with many tools already available, so that even a small or medium-sized enterprise can adopt Ethernet in their instrumentation. This will also be important, for example, for diagnostic tools.
Mm-hmm. Sounds like an easy change, maybe then in the field. We'll talk about that later in our networking launch. So thanks a lot, Andreas, for your presentation. And as I said, the networking launch will take part in like half an hour. It's 10 a.m. German time, and join us then. You just have to change the room. Just click on to conference, and then you'll be in our networking launch. See you later.